In this lecture, we're going to review some of the basic principles of measurement and the different levels of measurement along different scales. And one of the key principles of quantifying our observations is this concept of precision. And precision refers to the exactness of a measure and is considered a reflection of the sensitivity of the testing instrument. And we look at some examples here. In measuring heart rate, this is a picture of a standard heart rate monitor. Heart rate is typically measured in whole number units. However, depending upon the type of technology, heart rate can be measured to the first, second, third, even fourth decimal place. And that would illustrate an increasing level of precision. However, the usefulness or meaningfulness of increasing the precision, despite the fact that technology would allow it, may not particularly be useful to the researcher. And so the degree of precision really depends upon the characteristic that is being quantified. Surveys and questionnaires do have a degree of precision, and the question as to whether to add more precision means that the questions would need to add additional selection options for the people that fill out the survey or more categories, but by adding more and more to get that additional precision, does that add any more meaningful information? And so once again, the answer to that question really depends upon the research question and the characteristic the researchers are trying to quantify. There are typically four measurement levels along measurement scales, and in these next few slides we'll talk about these four, or I'll talk about these four measurement scales, starting with the simplest scale, which is called the nominal scale. And so the nominal scale is a way of quantifying observations just by assigning observations to unique categories. And in doing so, the nominal scale is really just an identification score. It doesn't actually measure the amount of the observation or assign any particular value. And so really what we're doing here is we're just counting the number of occurrences in each category. And we'll take a look at a few examples here shortly. And so the classification of our observations into different groups or categories or responses, that categorization does not have any particular order to it. Once again, meaning that we're not quantifying any inherent value to our observations. Some examples here. If I wish to ask the people in the general public if they felt that professional athletes make too much money, I would pose my question on my questionnaire like this. I would just ask, do professional athletes make too much money? And people would either check a box that says yes or check a box that says no. And as a researcher, I would count how many people said yes, and I would count how many people said no. And so that count is the numerical value of my observation. Another example here relates to university academic departments. This is a nominal scale, so I might wish to count how many students are majoring in psychology, biology, history. Once again, there is no particular or natural order to these different categories, and there's no inherent value to these different categories. It's just how many students are registered in each of these particular academic majors. Another category is sex at birth, and so there are two categories in this particular definition for female and male. Note that this does not make reference to any particular species, but just if we were to define sex at birth with these two categories, we would just identify whether that offspring is a female or that offspring is a male. And to review our categorical variables, because we only have two categories, we would call this a dichotomous variable. Another definition for sex at birth is a variant definition where the offspring would be classified as female or male or intersex if that offspring possesses traits that would classify them as a female and as a male. So this is this definition now has three categories. In terms of gender, we would have three different categories if we were to define gender in this manner. So we would define as man, non-binary woman, or I'm sorry, non-binary person, or woman. And these latter three bullet points here under the examples are the actual definitions by the federal government in Canada here. And so here is a link to the definition established by Statistics Canada. Now, if we are to conduct research that would use a nominal scale, there are three criteria that need to be met. First of all, the data must be mutually exclusive so that one case or one observation can only be applied to one of the categories. So there must be one and only one category for each case. So if you have one offspring, you would not quantify, you would not assign the offspring to man, non-binary person, and woman at the same time. There would have to be a one and only one category. The categories should be exhaustive. So the category must exist for every possible score that might be found. And so once again, it's very important to note that we're not dealing with continuous data. These are discrete so that one case, one observation would be assigned to one category. And as a result, we would have a very finite number of categories. And just take a look at these examples here where we have a dichotomous variable in the first bullet item. This, of course, is not dichotomous because there's more than two categories dichotomous, three categories, and we have, once again, three categories. The third criteria is that it must be homogeneous in that within each category, the cases assigned should have similar traits that would qualify them into that one category. And so the nominal scale is considered the lowest level of the measurement scales, or the simplest level of the measurement scales. Moving up one level is the ordinal scale, and the ordinal scale is very similar to the nominal scale in that we define discrete categories for what it is we want to measure. However, there is a natural order to the item that we are measuring, and as a result, the scores that we would assign for the different categories would indicate just a position between the items, not an inherent quantity, but just the order is identified. So some examples might include income level, and so we would have people that would be categorized as either low income, middle income, high, or very high. So the three criteria on slide 28 also has to be met for the ordinal scale. But you notice that based upon the numerical value of the income level, a person would be categorized into one of these four groups. In terms of personality traits, one such personality trait which is referred to as extroversion, so the degree to which we would say a person is an extrovert, can be quantified in terms of low to high, typically with a Likert type of scale. Opinion surveys sometimes have a natural order to these outcomes from agree to strongly agree. So here we have this natural order where a person might agree to a question or have a very definitive agreement to that question. The example you see here on this picture, here we see a physiotherapist assessing the strength of this case, the person's hamstring muscle with a suspected muscular injury. And the measurement of clinical strength, in this case, clinical measure of muscle strength, is very often can be categorized as an ordinal scale. So clinicians, physiotherapists, will often use a graded scale from 5 to 0, and that graded scale does have a qualitative value. Putting a numerical value to it will help to guide use of the scale between therapists. And from a clinical perspective and from a research perspective, if we choose to use an ordinal scale to quantify our observations, even though we have, in this case, 6 categories, each category should be clearly defined as to whether a person or an observation would be assigned to any of these different categories. And remember, a person can be assigned to one and only one category. Moving up, one more level is what's called the interval scale, and this is where we start to describe the amount, the quantity that exists using our numerical values. And so on an interval scale, we assume that there is an equal amount that separates scores. So we can also say that these scales are linear in that there is an equal distance between the numerical values we would use to measure our observations. The interval scale is unique in that this is a scale that can have negative numbers, and as a result, the value of 0 would just indicate a reference point, whether something is in the negative direction or in the positive direction. And the two examples I'm going to use here, so scratch age, is temperature in Celsius, measured in Celsius or Fahrenheit, and income level in dollars. So in this example, the variables of these two examples, so once again we're going to scratch out age here, include temperature and income. We would just label these variables as such, and our variables in this case have units, and we did not see that with the nominal and the ordinal scale. So the unit for temperature is Celsius or Fahrenheit, and we know that temperature can take on negative values. In terms of dollars, can dollars take on a negative value? If it does, then we would be referring to debt rather than a surplus. So oftentimes a negative dollar value would suggest that a company or a business or a person owes more money than what they're taking in, and that is usually indicated as debt. The highest level, it is somewhat similar to the interval scale, is the ratio scale. So the ratio scale does actually represent the true amount of how much that variable is present, and these scores are scaled to a true 0. And on the ratio scale, a 0 would indicate the absence of the quantity we're trying to capture. And so some examples include employee salaries and age. And so in terms of the employee's salary, we know that an employee cannot get paid less than 0. If an employee gets paid less than 0, that doesn't exist. But if an employee gets paid 0, they receive no money at all. So the 0 represents the absence of money. And the way we measure chronological age is from the point of birth, and so we don't quantify the age of a person pre-birth. So the point 0 represents that reference point after which, as that person ages, the chronological value assigned to age goes up. And so the important point to note here on this slide is that the interval or ratio variables, there is overlap with some of the basic characteristics that we would use to define an interval or ratio scale. So this ends our last slide here for Unit